Okay, ladies and gentlemen, we have a special segment on special triangles. Now, special triangles 1, 1, root 2 for a 45, 45, 90. 30, 60, 90 is a 1, root 3, and 2. We already talked about those. Now let's talk about the 4 other special triangles you must know. Here it is, the 90-degree triangle. It is 1, 1, 0. That's it, special triangle. Now, for some of you go, whoa, wait a minute. I don't see 3 sides. And I would agree with you. The way you create that is you take your side and it moves, dropping your reference angle every time. And as you move around, even though the radius stays constant, the opposite side is going to be getting longer and longer and longer, while the adjacent side is going to be getting shorter and shorter and shorter. By moving this up through, eventually you come to a place where if it were at 89.99 degrees, what you would end up with is a triangle where the opposite side is 0.999 if the hypotenuse is 1, and the adjacent side is so tiny that it becomes 0.00001. Now, in that case, it is still a triangle, because it has 3 distinct sides, hypotenuse, opposite, and adjacent. But as soon as you actually bring it straight up, that means for this to reach from the top back to the origin, that the hypotenuse and the opposite side have to have the same length. The adjacent side, on the other hand, is actually going to disappear, so it's no longer a triangle. But not only does it go from 3 sides to 2 sides, it goes from 3 sides to 1 side, 1 line. And so it becomes a degenerate triangle. But the degenerate triangles allow us to fill in the blanks at 90, at 180, at 0, and at 270. So I have a degenerate that looks as follows. Hypotenuse 1, opposite 1. And you'll notice there's a reason the opposite is on this side, because over here, as we make it go higher, the opposite side is always on the right. It's to the right, it's to the right, so it stays to the right. And the adjacent would be 0. Now, as we come around, radius stays the same. The opposite side switches to the left, and the adjacent side is still along the x. So that when I get down here to 180, the hypotenuse is still 1. The opposite side has gotten shorter and shorter and shorter until the opposite side is 0, and the adjacent side has to be the same exact length as the hypotenuse, but since the adjacent side is going backwards, it's -1. Finally, you get down to 270, the hypotenuse is 1, the opposite side is now -1 because it's gotten larger again, because it's stretching, and you end up with the adjacent side of getting shorter, 0 again, until you roll all the way around here. The hypotenuse at 0 is 1, the adjacent side is 1, and the opposite side is 0. So you have these 4 degenerate triangles that you have to add in. Should already know them, but just in case, that's where they come from. That's how they're created. And you're going to need them over and over and over again. Here are 7 homework problems that you need to have accomplished. You'll notice some are in degrees, some are in radians, some are actually larger than a full rotation. So you're going to have to figure out where as it goes around and around and around, where does it stop? And then once you figure out where it stops, draw the appropriate reference triangle. So there you go.